All right, so I'm going to help you find the mean absolute deviation and get some feedback on how you did on that. So my number one thing to say on the MAD is you got to organize your work. You got to get it set up in a table or something so you can keep track of what you're doing. And also, it's just like finding the mean, but with distances instead. So that means we still add stuff up and then divide at the end. But the only difference is since we have to find those distances, we're going to have to subtract each value from the mean. So for example, with chock full, we had 17, 19, and then 3 18s. And that was the number of cookies there were, or the number of chocolate chips there were in each cookie. So with 18 chocolate chips on average, the mean, that means this is 1 away from the mean. 19 is also 1 away. Even though it's 1 above, it's still 1 away. So it's like I'm taking 18 minus 17 and 19 minus 18 to find those distances. So I have 0 distances right there because they're all the same as the mean. So not very much deviation. But here's the key thing. It's not just the subtraction. It's the mean absolute deviation. So it's what's the mean of this data right here? Well, it adds up to 2, and then it gets divided by 5. That will tell us our MAD, and when you do that with a calculator, you end up at 0.4. Many of you just add this up and say the MAD is 2. Nope, we got to divide it by 5 to actually figure out, on average, how far away are the points from the center from the mean. So let's try this with all chock. And all chock we can already tell has a lot more variation. We have 22, 15, 14, 21, and 18. So already more variation than the one we just looked at. Again, the mean was 18, so I think how far away is 22 from 18? It is 4 away. How far away is 15 from 18? It's 3 away, 4 away, 3 away, and then no variation in the last one. So again, it's not enough just to add these up. We add them up and we get 14 in this situation. That's not our MAD though. Our MAD is our result after you divide by the number of values. And there's 5 values here, and so we end up with 2.8 for our mean absolute deviation. So here, a lower mean absolute deviation, that means lower variability. That means it's easy to predict, easy prediction. And here, this is higher variability, which means it's a more difficult prediction. So for example, if you ask me, can you predict how many chocolate chips there are in an all chocolate cookie? I would say, no, I can't very easily because it has high variability. It could be anywhere from 14 to 22. It's very variable. But when I look at chock full, it's pretty easy to predict. If you said, can you guess? I'd say, oh, probably 17 or 18. Or 18 is probably the best guess since it's not deviating too much from the center of 18. So use this to think about things as you go into making your corrections of your analysis and as you think about which cookie you would recommend for the party.